All right, good morning, everybody. So today we're going to start the what they call the Jefferson's method, and it is a divisor method. So basically, when it's a divisor method, you're going to manipulate the divisor, or you're going to modify it in the apportionment, and that's basically what we're going to do today. All right, so the first part is just like before, we are going to find our quota. And how we do that is the quota is just the state population divided by that standard divide or the divisor that we came up with, just like we did with the Hamilton method. Okay. The only difference with this versus the Hamilton method, if you think about the Hamilton method, what we did was we manipulated the quotas and rounded as we needed to, based on the rules of the Hamilton method. So, what the divisor method says we're going to do is to get the quotas that we want, then we need to change this divisor so that it's going to change this to give us what we want. And so, to do that, to create a bigger quota, so if I want my quota to go bigger, I need to use a smaller divisor. Okay? So if I want a bigger quota, I need a smaller divisor. And vice versa, if I need a smaller quota, then I'm going to need to use a bigger divisor or larger divisor. Okay? All right, so that being said, we now can look at these examples right here. So it said, consider the expression 250 over x, where x was a 6. Which new value of x would result in a larger answer? Okay, so I want my quota to go bigger. So to get a bigger quota, I need to use a smaller divisor. So if my divisor was 6, then I'm going to have to go to 5. 5 would be my smaller divisor. Now it says circle all that apply, but that's the only number in this case that would apply. All right, same thing here. Consider the expression where x was a 9. Which new value of x will result in a smaller answer? Okay, so if I want remember, think about what we're doing here. My answer would be my quota. Okay. My answer, that divided that, gives me my quota. So if I want the answer to be smaller, so if I want a smaller quota, I need a bigger divisor. So if my divisor was already 9, a bigger divisor would be what? 10 and 12 would be our possibilities there. Same thing with number 3. Consider the expression duh over y, where y is 125. Which new value of x will result in a smaller answer? So if I want a smaller quota, I need bigger divisors. So 125, I need to go bigger, which would be 127. And then last but not least, consider the expression 49 over z, where z is 0.35. Which new value of x will result in a larger answer? Okay, so what was it again? Bigger quotas, I need a smaller divisor. So z needs to be smaller than what it is. And if it's already 0.35, what's going to be smaller would be 0.15, 0.275, and 0.09 would all be smaller. 3.5 is bigger, so that wouldn't work. Okay? All right. So that's just kind of like a little quick adjustment there. So the goal of the Jefferson method is that we need to make the quotas bigger so that the lower quotas will become the exact apportionment. Okay? So we're going to kind of do like we're going to start off just like the Hamilton method. Okay? We're going to start off just like the Hamilton method. We're going to find a standard divisor. and we're going to find our lower quotas, just like we did with Hamilton. Okay? Number 2, though, is then we need to find a suitable modern modified divisor. Okay? So what we're going to do, where with Hamilton we changed the quotas, here we're going to change the divisor, that number that we divided by. And we're going to keep changing it until those lower quotas turn in to our apportionment. Okay? All right. Questions there. Now, so this is kind of how the process works. And they kind of do like a little flow chart so you can see. And this will make a little bit more sense when we do an example. Okay? So we're going to do our divisor. We're going to calculate everything, and we're going to figure out how many seats based on the lower quotas. If it's, if the number of seats is less than M, the ones we need, then we need to go to another smaller divisor. We need to make our divisor smaller and try again. If T, our total, is greater than the number of seats that we had, then we need to go to a larger number, a larger modified divisor, and we're going to try this whole process again. And you basically just keep doing this until you get where the apportionment equals the total number of seats that you had. Okay? And you just kind of keep the process going. Like I said, this will make more sense here when we look at our first example. All right. So now, in terms of us guessing our divisor, there's real no art to this. We're literally just going to start kind of guessing numbers, okay? So like for instance, this one says, well, if 100 created over apportionment and 105 created below, then what should our next guess be? Well, then it should be a number between 100 and 105. So we could maybe do like a 102 or a 103. All right. But we're literally just kind of guessing. But in this case, 100 was over the number and 105 was below the number. So we needed to pick a number in between. On this one, if the divisor is 64 is over and 66.5 is over, then what should our next guess be? Well, once again, if we're over, okay, go back. When we're over what we're supposed to be, T is greater than M, then we need to go larger when we modify our divisor. We need to go larger, going back to that little chart over there. So in this case, I would need to do something that is over 66.5. Okay? And last but not least, if the divisor created was below what we want, go back to our little chart. So if we're less than what we want, what do we need to do? We need to make our quota go up, so we need a smaller number. So if the when we guessed 135 and it was below, and 117 created and it was below, then we need a number. We need to keep going lower, so we need something below 117. We need to make our divisor small. So if we're under, then we need to make our divisor smaller so that my quota goes up. Okay? If we're under, we need to make our divisor smaller so that our quota goes up. All right. Let us look at our first example here then. All right. So like I said earlier, there are 15 scholarships to be apportioned among the English, history, and psychology majors. All right. So this first part, you're going to do just like we did the Hamilton method. We're going to find our standard divisor. How do I do that? I add them all together. Luckily, they've done that for me. So 1088, and we divide by the number of seats we have. So I had 1088 divided by 15, and that gives me my standard divisor to be 72.53. Okay? All right. And then we find our quotas. And how do we find our quotas again? We take our population divided by the standard divisor, and that gives me my standard quota. So 231 divided by 72.53 is going to give me 3.185. 502 divided by 72.53 is going to give me 6.921. And then 355 divided by the 72.53 is 4.895. Okay. Now remember, in the context of this problem, what are we talking about here? We're saying that for every 72.5 students, you should give out a scholarship. And that's why we have the 3, the 6, and the 4. All right. And then we find our lower quotas. Remember, this is just like the Hamilton method. So this would be 3. Remember, we basically just dropped the decimal places. Drop the decimal places. This was 6. Drop the decimal places. That's 4. And this is where we're going to find our total. So 3 plus 6. 3 plus 6 plus 4 gives me 13. All right. Now, this is where we divide off here. If you remember, by the Hamilton method, we said, okay, well, there's 15 scholarships. We've given out 13. And then we apportion the rest based on the decimal places. So they would get 1 because 0.9. And then they would have gotten 1 because of 0.8. And that would have been our 15. All right. But that's not how Jefferson method works. If you remember, we talked a little bit about this. We said the Hamilton method was kind of biased a little bit to the, I want to say it was the larger states, smaller states. I can't remember now. So we have to change it. And so what we do, instead of like by Hamilton, by rounding by the decimal places, we are going to change what we divided by. All right. We're going to change what we divided by. And now this is going to be the try for the most. We need our numbers to go up. So once again, think about going back to our little rule here, just in case you ever forget. Right now, we're 13 is less than 15. We have 15 to give out. We've only given out 13. So we need to make our divisor smaller so that my quota goes up. Remember? So what we're going to do is now we're just going to pick some numbers. Well, my divisor was 72.53. So let's just try 72. And we're going to do the process again. 231 divided by, I don't know why I said 52 right there. 72. So now we're going to do the 231 divided by 72 is 3.208. This is 6.97. 502 divided by 72 gave me that. And then 355 divided by 72 gave me 4.93. Well, this is still 3, 6, and 4, which is still my 13. All right. So we need to go lower. So let's try. And like I said, there's no art to this. I'm literally just trying numbers. And, this time I'm only going by ones. You might need to go more or less than that next time. But we're going to try 71 this time. So now 231 divided by 71 would give me 3.254. This would be 7.07. And this turns out to be 5. And so we have 3, 7, and 5, which is my 15. And that's exactly what I wanted. And so, yay, my apportionment is done and life is good. All right, that's it for that example.